And we're continuing on where we left off, and this is a special case. I want to start here. Keep in mind how this works. We have a problem. We know how to take a derivative. So again, there's always space left for multiple things. I'm going to take this space and explain a quick thing really here. If I take a derivative of x to the n, that's easy. Bring the power down, subtract 1 from the power. Very good. If I take a derivative of n to the x, an exponential, well, that's n to the x times natural log of n. But what do you do when you have a variable raised to a variable? We've never came across that. You can't bring the power down and subtract 1 from the power. That's not allowed. You have two options. You could say y equal. Anytime I'm stuck with that, I introduce e to the natural log of x to the cosine of x. And that's the power of logs and exponentials. I could say y equal, move this to the front, properties of logs. And I could say dy dx will be derivative of an exponential is the exponential times the product rule. Derivative of the first times the second plus the first times derivative of the second. And if I really think about it, this right here is actually this right here. So if I go back and say y prime equal x to the cosine of x times whatever that is. There is no other way of doing this problem. There's no shortcut. The alternative is really a copy of this. Anytime I look at something like this and I figure that I'm having an issue with that, I'll say, you know what? Take natural log of both sides. Whenever I'm dealing with a power, and I could say natural log of y equal, you could move this up front and say that's the cosine of x, natural log of x. And now if I take a derivative of both sides with respect to x, that is 1 over y times y prime, implicit differentiation. The product rule, negative sine of x times natural log of x plus cosine of x times 1 over x. And I could say y prime equal y times negative sine of x natural log of x plus cosine of x over x. And I can't leave a y prime in there, a y in the answer. What does y equal? Y equal x to the cosine of x. So either of those will do. I am going to stick this time around with this notation. That's going to come up in section 6.8 as well, which is among the most crucial sections in this course. The same deal, if I look at this, this is x raised to the 1/2 raised to the x. That's really x to the x over 2. I don't know how to take a derivative of this. We never had this before. So I'm going to say y equal e to the natural log of x to the x over 2. And by properties of logs, I'm going to move this up front. And when I say find y prime, derivative of an exponential is the exponential times product rule, derivative of the first times the second plus the first times derivative of the second. And I am aware that this right here is actually this right here. I would have to write that. And this is natural log of x over 2 plus 1/2. And that's how we do this. I am going to do the next problem using this notation. So it's your choice. They're really the same thing. I see that I have a power raised to a power, and I don't know how to do that. So I would say natural log of y equal natural log of the sine of x raised to the natural log of x. Bring that up front. Natural log of y will equal natural log of x times natural log of the sine of x. And if I take a derivative of both sides, I will get 1 over y prime equaling product rule. 1 over x times natural log of the sine of x plus natural log of x times 1 over the sine of x by the chain rule times the derivative of sine, which is cosine. So if I actually cross multiply, I'll get y prime to equal y times natural log of the sine of x over x plus natural log of x cotan of x. And I could say y prime equal, y initially was radical x raised to the x times whatever that is. And the last practice problem on those I would like you to do would be this. I'm going to do this by using, so I'm alternating. I'm going to say y equal e to the natural log of the natural log raised to the cosine of x. Move that up front. I'm going to say y equal e to the cosine of x times natural log of natural log of x. And if I differentiate both sides, derivative of an exponential with a base e is the exponential with base e times the derivative of the exponent by the chain rule, product rule. Derivative of sine is negative the sine of x times natural log of x plus cosine of x. Derivative of a natural log is 1 over the argument times the derivative of the argument, which is 1 over x. And I would say y prime equal, hey, this was the original. The original was actually natural log of x to the cosine of x, and whatever that is, negative sine of x times natural log of natural log of x plus the cosine of x over x natural log of x. Integration, well, when I take a derivative, I multiply by natural log of 5. When I take an antiderivative, I divide because that's reversing right there. So when I take a derivative of b to the x, I multiply by natural log of b. I covered that. Let me get rid of all of these arrows. And when I take an integral, instead of multiplying, I divide by natural log of b. Remember that. And if I integrate, this is a power function. That would be x to the 6 over 6 plus derivative of exponential is the exponential, integral of exponential is the exponential. If you take a derivative, you multiply. Antiderivative, you divide. Don't forget the c. Here, if I let u equal x squared, du is 2x dx. So I could say this is the integral of 2 to the u. And I could say x dx is really a 1/2 with a du. And wouldn't that be 1/2? Integral is 2 to the u over natural log of 2 plus c. And that would be 1 over twice natural log of 2 times 2. U was x squared plus c. And if I get to the last problem, there are a couple of ways I could do that. In 7.4, you're going to learn a new trick. For now, we let u equal the denominator of a fraction, if you remember. The power, the argument of a log. Du will be 2 to the x times natural log of 2 du. So this will become the integral. This is my u. And 2 to the x dx, I would divide both sides by natural log of 2, 1 over natural log of 2 du. That is 1 over natural log of 2 times natural log of absolute value of u plus c. And what's u? U happen to be 2 to the x plus 1. You really don't need absolute value on 2 to the x plus 1 because that's always positive, but I don't mind you leaving that on. There's the homework, and that concludes this section.